Hey guys, thanks for stopping by. It's Chuck, Outside Screwball, and I appreciate you stopping by today. We won't be doing any work here today. We're going to go on a road trip. We're going to go over to my buddy Dale's shop. It's about a 20-minute drive from here. We did a previous video some time ago on the Leinhard Rose lathe, and Dale gave me a call. He's got the geometric chuck set up into the lathe, and he's going to do a demonstration for us. I'm kind of excited to go see it. I understand what it can do, and we kind of showed some of the processes that this lathe could do in the previous video, and I'll put a link there on the screen if you guys want to go find it. But I think you guys will enjoy it, and we'll take off. And I'm going to do my best filming this camera as we try to get in close on things. Sometimes it'll go out of focus, so if we have any issues there, I apologize in advance. Stick with me, and when I produce the video, if I see anything that's really bad, I'll cut it out. Alright guys, let's hit the road. See you shortly. Hey guys, we're back with my friend Dale, and today he's installed the geometric chuck on the front of the lathe, and he's going to show us how it's used. But before we get into that, I'm going to have Dale kind of just give us a brief explanation of the machine again for anybody that didn't see the first video on it. I'll post a link right now on the first video. You can always go see that, but I'll turn it over to Dale here.
All right, this is a Leinhard Rose engine, and what that means is it's got rosettes here. These are called rosettes. They're like cams, and the head of the lathe here is on a pivot, so it can move back and forth. The shaft is also is able to slide back and forth in this direction. So it can rock and pump. And that's done by springs. There's a large spring over here that for the rocking motion. And there's another spring in the back for the pumping motion.
Okay.
And then the rosettes move the head, and the spring moves it back. Is kind of the way it works. This machine is hand cranked. Crank it by hand, or I have a motor down there that I can attach the motor to and turn the speed down to a couple RPMs per minute. This machine was made in 1919 by the Leinhard company. It's a Swiss company. They were used in the jewelry industry in the 20s and 30s mostly. Actually, they date back to the 1600s, but they were mostly used in the jewelry industry. This one was back east somewhere. It was stored in a barn for like 30 years before I found it, and I had it shipped out here from actually Tennessee.
What wood are we turning there?
Huh?
What wood is that?
It's African blackwood.
African blackwood.
What I got on here now is a plant two-stage geometric chuck, and it's got two stages, in that it has two cross slides on it. It's one here and one here, and you can offset them to whatever you want, depending on the diameter that you want to turn and the pattern that you want to make. It's a very complicated thing, actually. It has a gear, forward and reverse. And what this thing does is it makes loops. And the forward and reverse, if it's forward, it makes an outside loop. If it's in reverse, it makes an inside loop. And that's what that does. So that's what this gear train back here for. Here we have a pinion gear. That's a drive gear. And this is where I met Chuck, actually. He was kind enough to let me use his mill, and together we made 14 gears. We made some pinion gears, and we made some, I guess these are called idler gears or whatever. It's part of the gear train. These are the gears that we made. I'll show you those here. These are the idler gears. And this bunch here is the pinion gears. The pinion gears have a hex head because they're drive gears.
That was a lot of fun that day.
So we got to make some gears, which was very cool.
And I didn't film it that day.
Anyway, one of those gears that we made is right here. And I believe this is a 36 tooth gear.
Okay.
And I believe this is a 60 tooth. And anyway, the combination of gears that these are change gears. I also made some other stuff. There's a link here. This link is so you can add another gear out here. Actually, here's the stuff that goes with the link. And these I made. These are specialized screws. This is the other half of that link. And you can also stick a gear out here, and this link goes back over and connects to this this plate right here, and that allows you to add another gear out here. So I can actually put a bunch of different gears,
which changes the spiral.
Yes, which changes the it changes the number of loops.
Okay.
And the two stage, there's another set of gears out here, and they are change gears also. And when you engage the second stage, it'll make loops in loops, a double set of loops.
And you taught all this stuff to yourself.
Yes.
Right.
Yes.
Yes.
Yes. This chuck was probably made somewhere in the late 1800s, 1880 to 1900, and it was made by Plant, and he's an English maker. And there's a number of different styles of these. Holtzaffel made one. There's a number of different people that made them. But when I got this, it was frozen up, but it was just frozen from sticky grease. So I couldn't move it at all. So I had to take it all apart and figure it out and put it all back together. And so what we're going to do now, I also had to make something else in the back here. I had to make this plate to attach to the Leinhard to engage the geometric chuck. We also had to make threaded adapters because the threads on the Plant geometric chuck are 9.45 threads per inch, which is nobody uses anymore. And the threads on this are 11 threads per inch. So kind of odd threads. So I had to make adapters to adapt the chuck to the lathe. And then also I had to make another adapter out here to attach 1x8 threads to 9.45 threads here. So it was a lot of fun making all these things that are weird. So this is what we're doing now. When I crank this around, there's a cutter out here on the end, and what we're going to do is we're going to make a design in the top similar to the one that we did last time.
Right.
Yeah, I've got the tops all finished. The whole body of the box is actually done right now, and I'm just turning the last thing on the top.
And that cutter you said is a carbide. And
yeah, the carbide is a 16th inch carbide cutter.
In the drive mechanism, that's you built all that.
Yes. This is all I built. All this stuff. There's a motor over here that turns at I think 2,500 RPMs, and then I've put a wheel on top, so it's actually going faster than that.
Okay.
You know, I put a different size pulley on top, and it'll go up to like 10,000 RPMs, maybe 20,000 RPMs.
Oh.
So it flies like a router.
Uh-huh.
Okay.
Yeah.
And it's connected to a controller, and I can control the speed of the cutter.
Oh, sweet.
So
Oops. Oh, no. All right.
these little bearings will not take the 20,000 RPM, so
Yeah.
you can't use it at full speed.
And then moving the camera here, the
Yeah, I have a Hardage cross slide.
Let me hold it up here.
Yeah, you can do that. I have a Hardage cross slide here that's that I've adapted to the original cross slide stand for the lathe.
Right.
So it just slides on top. These Hardage cross slides are extremely accurate. You can turn them at angles. They already have a measurement for that doubles the when you're cutting the diameter. It automatically figures it out for
okay.
you. Yes.
Yeah.
So this is in 200 increments.
Right.
So this is the in and out is in 100.
100. Okay.
So it already tells you, how much you're actually taking off.
Okay.
Yeah, let me sit back there. That works.
So I'll try to get in close here so you guys can see the cutter.
It's very small.
Yeah, there you can see it. Hopefully the camera's focusing enough there. Cool. Okay.
All right, so this should not take too long.
Let me. We're going to stop and we'll get set up, and then we'll come right back and watch it make some sawdust. Okay, we're back, and I've tried to position the camera so we can get a good view, and Dale's going to go for it here.
Just go 5,000, you can see how that goes. Now I've got it set up for a 20 loop circle. I'm going to call it a circle. 20 loops in this pattern. So it's and I've preset up the machine. It takes a while to get everything centered on here. Everything has to be level, centered, or it doesn't come out right.
Quantify what's a while.
It'd probably take me an hour to set up.
Hour? Oh, that's not bad. Yeah. Let's see if I can zoom in a little closer to you guys.
But to make the pattern, it has to go around 20 times. And then I have to adjust the depth and go and more and keep going until I get to the depth that I want it to be.
Try to move you guys so you can get a picture of the geometric chuck. So pardon the wiggling.
Now completed 20 loops. I'm going to add 5 more thousandths to the depth.
Now, are the roses working right now too? Back
No,
here?
they're not.
They're not engaged at the
No,
moment.
they're not engaged at all.
So it's all the geometric chuck.
To make the rosettes work, you have to put a rubber or a cam follower
Right.
against them.
Right.
Yeah.
And it's hard to see right now, but is that cross slide moving back and forth on the chuck?
No, it's not.
It's not. Okay.
No, it's fixed at the diameter that I want. I've got it out over here. You see the first stage?
Right.
I have it out 11 cranks, I believe.
Okay.
It's 11 turns out. And that's to get the diameter I want on the pattern.
The white pipe you see there in the screen is a vacuum setup he has. Get the vacuum off just so we can hear. Otherwise, he really wouldn't have as much sawdust here. And what's the wood you're turning there?
It's African blackwood,
African blackwood.
which is about the next thing to cut and steel.
Yeah.
Now, if I put a different cutter on here,
Uh-huh.
it would change the pattern a whole lot.
Just the cutter alone.
Just the cutter alone, yes. And that goes for diameter of cutter and the width of the cutter. So this is making a very fine line.
And he's controlling depth of cut back here on this guy.
I'm going to crank it in another 5,000, so I'm at 20,000 now.
And what would you typically, how deep would you go?
You know, on these, I would like to go till it makes a point.
In the center?
No, not in the center.
Oh.
A point on the facets.
Okay.
Now this one is not going to make a point on all the facets, but the center part, I should be able to get to a V point. You're not very excited. You're just sitting here cranking away.
Cranking away.
Actually, for this, I should have probably hooked up the motor.
So we stopped the camera there for a few, and Dale went ahead and hooked up his electric motor so that he doesn't actually have to do the hand cranking. And you can see that the lathe is turning, and he can sit back and just crank in the feed as it's necessary. And it's on a rheostat, so the speed is adjustable. So we were talking about, as we stopped the camera too, go ahead and explain what you were shooting for, Dale, on the...
Well, let me start off.
Yeah.
Right in the center here, I would like this little flower pattern to come to a sharp V point.
Okay.
And hopefully I can do it with that 16th inch cutter. Now here's another one that I've done. That was done with a little larger cutter. And you can see it makes a wider groove. And it's easier to make, what you shoot for in this case is probably V's everywhere. It comes up to a point. These have some flat spots on top.
Mm-hmm.
Sometimes you like that because it reflects the light nice. Sometimes you want it to come to go deep enough to make a V there.
Uh-huh.
So everything comes to a point.
Uh-huh.
And that requires going fairly deep.
Okay.
So all these patterns look good. You
Yeah.
know, it just depends on what you're looking for.
What appeals to the eye,
Right.
yeah. And
And
is that, what wood is that? Is that?
This is, again, African
African
blackwood.
blackwood.
Yeah.
Okay.
Now here's another pattern on the back. This was made with the same thing, and this is 3 loops.
Okay.
The one we're doing now is 20 loops.
Okay.
This side is 20 loops. So you can see what this thing can do.
And the three...
And this is forward, this is reverse.
Wow. And the 3 loops just as a change in your gearing,
Right.
in the gears.
And you can, with this chuck, you can also index this. If I wanted to go a couple of degrees, I think there's 96 divisions on this wheel. And if I wanted to go 1 click, that would be divide 360 by 96, I guess. And that would be how many degrees 1 click is, which is probably 3.75, somewhere thereabouts.
Uh-huh.
So every tooth on here is like 3 degrees.
In the bot, there's 2 catches? Oh, it's the same catch. I see.
Yeah.
Yeah. And you have something similar back here?
Yeah, this back here again is an index, and you can offset it back here too.
Uh-huh.
So if I move this over a tooth, and then again, this is, I believe, is a different index than what's on front.
That's front, yeah.
So you can probably get just about a degree if you wanted offset on each one, and that's what we've done on this one. Is I've just moved it over like a degree.
Uh-huh.
And cut the same pattern, and you can see those are actually just 3 loops. I moved it over a degree, cut it again, moved it over again, cut it again.
Oh, I get it.
Skipped one,
Yeah.
and then cut 2 more.
Uh-huh.
So you can do unlimited.
Yeah.
Unlimited patterns.
Whatever your imagination
Yeah,
is.
yeah. Right. And this one on the outside, this is where the cutter turned right here. There's an inward loop,
Mm-hmm.
and it happened to be right on top of itself.
Hmm.
And that's why it gave you that pattern.
Mm-hmm.
So again, there's unlimited things you can do this. With the gears that me and Chuck made, I can do 1 loop, 2 loops, 3 loops, 4 loops, 5 loops, 6 loops, not 7, 8, not 9, 10, 11, not 11 either. The prime numbers are kind of out for most things.
Okay.
But the rest of them, you know, up to, you know, this one makes 20 loops. I'm sure after it gets 20, it gets pretty busy.
Yeah, I bet, yeah.
So I kind of stopped there because I didn't think I would need,
Yeah.
you know, anything above that because it gets just too messy.
What's the biggest diameter piece you've turned like this? Is it
This
pretty
is
much
about it,
about
you
it?
know.
Uh-huh.
Yeah,
okay?
yeah.
Just curious if you'd ever turn anything
The
much.
larger the pattern just expands,
Right, right.
you know. So yeah, and blackwood is doesn't come very big.
Right, that's,
You
yeah.
know, 3-inch square is about the
About
best
it,
you're
huh?
going to do on the blackwood. I mean, there are logs, but still, it's there are a lot of voids, a lot of bug holes in it sometimes.
Uh-huh.
So it's hard to get a large piece.
Just get another shot of it down here. Why it's static. And this is where the bumpers go that ride.
I can move these in and
Right.
to touch the rosettes.
And here's
And
the
I have another one
spring
on this
mechanism.
side
Right.
also.
Yeah.
So depending on which side you want to use, it makes a completely different pattern.
Right. Yeah, because
You know,
okay.
it makes the opposite over here if you want to rub on that side.
I was just clarifying with Dale, because you guys may have the same questions I have, but you're not here. So this outside perimeter of this top, these cuts were done using the rosette mechanism, and the top was in the horizontal position. So this indexing is only done on this direction. So, and you actually see that in the previous video that we did. Using the rosettes. This is the final closeout here. You can see the machine's running on its own, and Dale's got the vacuum going, picking up the dust, and quite the marvel to watch. I want to thank you, Dale, very much. So this is the actual cup that the top is being made for. Go ahead, Dale, explain what we have there.
This is 12-sided, 12-sided figure. I used the same rosette that I used on the last one on the straight line chuck.
That we filmed, right.
Right. And but I used a different rosette to make the decorations. I don't know if that shows
Yeah,
up really
I think it's showing up pretty good. Yeah. Nice.
And anyway, that's the top that's going to fit on this thing.
Cool. Looking through a magnifying glass there, so I don't know how this will show on the film, but we're trying it. Just doing his last final hand cranks to complete the cuts here. So Dale's taking the part out of the lathe, and you can see it. Go ahead and turn it a little bit, Dale, so you can see, or spin it, rotate it, and you can kind of see how it picks up the light different and how it shows. Now this, Dale would end up with this putting a coat of lacquer and then buffing the lacquer off and then finishing with some wax. Too cool. Great, thanks, Dale. you.